now we go to the different properties of minerals. Okay, so there are more than 4,000 minerals known to geologists, and what makes them unique from each other are their properties. These properties are what are used by geologists to differentiate one mineral from another. Okay, we have these different properties. The first one, we have luster. Okay, when we say luster, it refers to the way light reflects from the surface of the mineral. And so there are two types of luster. We have metallic luster and then a non-metallic luster. When we say metallic luster, these are generally opaque and exhibit a resplendent shine similar to a polished metal. So automatically, when a mineral looks like a metal, it exhibits a metallic luster, or if it looks like aluminum, then it exhibits metallic luster, something like that. Then we also have their non-metallic luster. Under non-metallic luster, we have different types. We have vitreous, like glassy, adamantine, or brilliant or diamond-like, resinous, silky, pearly, dull, or earthy, and then we have greasy, etc. Okay, let's look into this in more detail. First, we have metallic luster. Again, these are minerals that reflect light like metals. Metallic luster often tarnishes a dull luster. Okay, we have here examples. We have malachite and galena. And so if you're going to look at malachite, on the gray or on the silverish part, that is what we consider as metallic luster. Okay, that is the mineral of that stone or of that specimen. Okay, then we also have their galena, and so if you are going to look in at galena, you can see there the grayish part or the silver parts, that those exhibits a metallic luster. So when this metallic luster, or when these parts of the mineral is exposed to the atmosphere, it reacts with oxygen and then it often tarnishes. All right. Another example of a mineral that exhibits a metallic luster is what we call as pyrite. Okay, pyrite, metallic and then shiny luster. So if you're going to look at it, it looks like gold. Okay, pyrite is also known to be as fool's gold, simply because it is often, of course, for non-geologists, we would often mistake it as gold. Right? So actually, when you go to mining communities now, you can always, or you will always see pyrite just scattered outside mining tunnels. And so simply because these do not have market value. Unlike for gold, of course, we know very well those have market value. For pyrite, it doesn't have a market value. So it's just scattered around mining communities or mining tunnels. Right? Again, pyrite, it's also known to be as fool's gold. We now have here the different types of non-metallic luster, starting off with vitreous luster. Okay, so when we say vitreous luster, the minerals reflects light like glass. Okay, sometimes glassy luster is used instead of vitreous. Okay, again, when we say vitreous, as long as the mineral looks like a glass, then it exhibits a glassy or a vitreous luster. So examples, you have their fluorite, and then we also have their dogtooth calcite. And so they appear, or they seem like they're glass, but they're not. They're actually minerals. And so it's just that they exhibit vitreous luster. Okay? And so these are more examples of vitreous luster. Next off, under non-metallic luster, we have pearly luster. There's the luster of a pearl or a mother of pearl. It shows clearly on the cleavage surfaces of biotite and muscovite mica. So on the cleavages, or on the gaps or on the cracks of these minerals, you can see their whitish substances. Those are these minerals exhibit there a pearly luster. Okay, and so it's also shown by talc and selenite, or which is a variety of gypsum. So from these samples shown right here, and so those that looks like pearl, or the white parts there in the cleavages, those are pearly luster. Next, under non-metallic luster, we have silky luster, or the luster of silk. And so it occurs in minerals with a fibrous structure. Example, we have the satin spar, a fibrous form of gypsum. And so it shows this to good effect. Like, if you are going to look closely on this sample presented, or in this picture presented, there seem like a fibrous structure, or silk-like structure, or strand-like structures, and so that is what we call a silky luster. Then next we have resinous luster, or the luster of a resin, mineral that has a grainy appearance. Examples, we have the sphalerite, opal, and amber. This shows a resinous luster. Or another example, if a mineral looks like rugby, the color of a rugby. And so there, if that resembles, or if the mineral resembles the color of a rugby, then that can be considered to have a resinous luster. Next, we have the adamantine luster, or this is known to be the luster of a diamond. And so unlike, or comparing that to a vitreous luster, for vitreous luster, it's quite different. It simply appears like glass. Okay? But when we consider a diamond, especially for a polished diamond, it now exhibits an adamantine luster, or this one gives the shining effect of a diamond. But actually, diamonds don't shine. Okay? The reason why they appear to be shining is that they reflect light more efficiently. So it appears like they are shining. But of course, diamonds do not have their own source of light. So we cannot say, we cannot technically say that they are shining. Rather, it's better to say that diamonds refracts and reflects light more efficiently, so they don't shine. So the song, or the song lyric, "Shine bright like a diamond," that's technically wrong in the context of science. Okay, and so the type of luster is what we call as adamantine luster. Next, we have their dull or earthy luster. And so the mineral does not reflect light and has the same appearance as a soil. Minerals such as galena have metallic lusters on freshly broken surfaces, but they tarnish to dull and with prolonged exposure to the atmosphere. So from metallic luster, as I have said a while ago, if that gets exposed to the atmosphere and then reacts with oxygen, they tarnish, then eventually they become dull or earthy luster. So if a mineral already looks like it's simply a rock, or it's simply a soil, then that exhibits now a dull or earthy luster. Okay? Example shown here, we have limonite, which has a dull or earthy luster. Right? So that is on luster. Again, it's a property of mineral that shows how light is reflected by the mineral. The second property we have here is hardness. Okay, so when we say hardness, it's the ability of a mineral to resist abrasion or scratching on its surfaces. So it's not exactly how we define hardness in normal situations, right? So in geology, when we talk about hardness of minerals, it's the ability of the mineral to resist abrasion or scratching, right? So we have here Mohs scale. It's one way geologists use to measure the relative hardness of a mineral. And so it's a linear scale of 1 to 10, 1 being the softest and then 10 being the hardest, right? So how do we use the Mohs scale? And so we have here Mohs relative hardness level 1 to 10, and then on the first column you have their examples or mineral examples. So what are the properties, or how do you perform the scratch test? For number 1, for Mohs relative hardness scale 1, if that is scrapable with fingernail, then that has a hardness of 1. So you just by using your fingernail and then you're going to scratch on that mineral and then you see their scratches, then that mineral exhibit a hardness of 1 only. All right. For example, for Mohs relative hardness 2 or level 2, as it's scratchable still by fingernail, but this time you will be having a difficulty in scratching that mineral. Okay, and then number 3, if that's scrapable by copper coin. Number 4, it's if it's easily scraped with knife. Number 5, it's still scraped with knife, but then of course again, it varies on the difficulty of scraping into that mineral. Then for number 6, it's now scrapable by a steel file. Number 8, it now scratches a window glass. All right, so number 7 rather. So for number 7, you are now going to scratch the mineral into the glass. Okay, unlike for tests 1 to 6, you're going to scratch an object into the mineral. But this time for 7 to 10, you will now use the mineral to scratch other objects. So for number 7, if it is able now to scratch a window glass, then it is on level 7. Okay, number 8, if it scratches a quartz. Number 9, if it scratches topaz. And number 10, if it scratches corundum. Okay, so basically, number 10 or 10, the hardest mineral, we have their diamond. Okay, so diamond can scratch all other minerals. Okay, so that's being one of the hardest minerals, it can scratch all other minerals. But then, for example, a corundum with hardness level 9 only, it cannot scratch a diamond. Okay, now you will see here that for Mohs scale, it's quite subjective. What do I mean when I say subjective? Like for example, we are going to consider number 4 and number 5. And so number 4, it's easily scraped by a knife, and the number 5, it's still scraped with a knife. So we do not have exactly a concrete definition of easy. Okay, the word easy itself is quite subjective. So for one geologist, it might be easy for him, but then for the other geologist, it might not be that easy. So for that geologist, the hardness level may be 5, while for the other geologist might be 4. So we can see there the subjectiveness or subjectivity of the Mohs scale. All right. But then, of course, in the 4th column, you have the Rossi-Wall absolute hardness, which is now a more quantitative. It's now a more quantitative way of determining the hardness of a mineral. All right. So there, these are some of the materials that we use in identifying the hardness of a mineral. So as long as we have these basic kits, we can actually perform already Mohs hardness scale. And so just by using our fingernail, a steel nail, a copper coin, or a window glass, we can already determine the hardness of a mineral. And so these are some examples of minerals according to their hardness level. So we have their number 10, that's a diamond. It's an unpolished diamond, that's why it doesn't look so pretty. And so that is how a diamond would look like if it's just mined. Okay, so of course, in the mining communities in Africa, they mine for diamond, and then the diamond would usually appear like this one. Next, we have there at number 9, or on a softer perspective, we have there an example, a corundum. At number 8, a topaz. Number 7, we have a quartz. And then orthoclase feldspar. We have apatite, fluorite, and then we have calcite, gypsum, and then talc. Okay, talc now is known to be the softest mineral in terms of Mohs hardness scale because you can easily scrape that using your fingernail. Followed by gypsum, you can still scrape this with your fingernail, but it will be more difficult for you to do that. But still, you can scratch it using your fingernail, so it's on level 2 on Mohs hardness scale. Okay, that is on hardness. Now again, I mentioned a while ago the Mohs hardness scale. We have here a more detailed explanation on the disadvantages and advantages of using the Mohs hardness scale. On the pros or advantages, it's easy to do the test. As you've seen a while ago, by just using these everyday objects, we can easily perform Mohs hardness scale. Okay, it can be done anywhere, anytime, as long as the place is not dark. Mohs scale is highly relevant for field geologists to roughly identify minerals using scratch kits. Okay, again, because it's more convenient or it's